Hi, this is the Tempted podcast where we explore the latest open source, Linux, and IoT technologies and workflows that enable innovative teams to build products better. Today, we have a guest episode and we have Matt Madison with us. Hi, Matt.
Hi, guys.
So, Matt, it's glad that you are with us here. Matt is well known for maintaining the Nvidia BSP for your project, among many things he does. So, we'll know a lot more about him today. So, Matt, would you like to introduce yourself and tell us about who you are and what you do?
Yeah, sure. So I've been around for a long time now. I've been doing Yocto project stuff, related stuff. Probably I've been working with Yocto project since probably around 2010 thereabouts, which I think is when the Yocto project itself actually started. Before that, I was looking at open embedded. At the time, I was working for one of the large networking companies over in the Silicon Valley. And I was there working on trying to improve our embedded Linux support by introducing Yocto project tooling to try to organize things a little better in terms of how we build things. I left that company in 2015 or thereabouts. I went to work for a startup that was making use of. They had a product that was based on NXP IMX6 SoC, and they had a Yocto project build that they were they had almost kind of working at the time, but they needed somebody that had some expertise with the tool set. And at the same time, they were trying to get that product out the door. They were starting up a new project that was using this brandy new thing from Nvidia called the Jetson TX1 SoC, the modules that were based on the Jetson TX1. And so I needed to not only sort of organize their builds a little better for the existing product, but also try to come up with a distro, because they wanted to reuse a lot of the same stuff they had for the IMX6 based product in the new product. So I had to do a distro, multiple machines, all sharing a bunch of stuff. But in order to do that, I needed a BSP layer for the Nvidia Jetson. And at the time, there were a couple of layers out there that were kind of dabbling with that, but it wasn't anything that was really comprehensive. My boss at the startup was very open to having this kind of stuff, BSP support, basic tooling, be open source work. So I started putting together the meta-tegra layer. So there was no layer for the Jetsons for Yocto, so I decided to put together one. My boss was amenable to having that be open source, so I did it all in the open. And then that sort of took off from there. That company was acquired by another company, and so that company was acquired, and we continued with another product that was based off the Jetson TX2. So I updated the meta-tegra layer to support that product, and then I was interested in extending that to the rest of the Jetsons. Actually, bought some of the Xavier modules out of my development kits. Nvidia was offering discounts on some of them, which made it a little easier to do that. But I was kind of doing that as a hobby project on the side. Didn't have any real need to do that for the company. And people got interested in it because there were a lot of folks that were interested in making use of Nvidia's CUDA, all the TensorRT, all the machine learning stuff that they were promoting for those products in their own embedded projects. So it just kind of grew, and I kept maintaining that on the side beyond what I needed for the real products I was building. In my most recent job, we had That's another product that's based. We have a product that's based on the TX2. They were looking for somebody with Yocto project experience to help with getting that out the door. So I'm doing that again with the company I'm at now.
Why do you use Yocto instead of like Debian or Ubuntu on these platforms?
Well, yeah, that's a really good question because if you use Nvidia's Jetson Linux offering, which is what Nvidia uses as the basis for their BSP that they offer to their developers, that's essentially Ubuntu. And in fact, it's even more Ubuntu now than it was when they started because they've actually been working with the canonical Linux team, and so the kernel that you get now from Jetson Linux is the Ubuntu kernel, and all of the proprietary Nvidia drivers or drivers that talk to the proprietary Nvidia stuff that isn't upstreamed yet in the Linux kernel. That's all done and handled through out-of-tree kernel drivers now. But I don't know. I've been doing embedded systems work, not necessarily embedded Linux, probably since the around 2000 or thereabouts. Ubuntu seems like an okay desktop or server sort of operating system, but it isn't really well suited, I don't think, to embedded use because even the same would apply to Debian or any of the other distros you would normally think of for a desktop or server space, because it's pre-built binaries, and so they have to build it generically. It's not that performance you want to optimize it necessarily for the specific CPU that you've got. That's less of an issue, I think, these days on like 64-bit ARM processors than it was back when you were trying to wring out get every cycle's worth of performance out of the processors we used to use. But the fact that it's harder to customize, you need to be, you want to be able to include just the functionality that you need. There's no point, especially if you're doing over-the-air updates, there's no point in carrying around boatloads of software that you don't really need to make use of, just to keep update sizes down. Mm-hmm. And also, personally, I like to have control over the source. If I want to know what's going into the product, not that I don't trust, the Debian folks or Canonical to do due diligence on what goes into their distros, but that's my own personal thing. And then when I'm working for a company, I think the company should be accountable for what goes into it. And I think it's easier to be accountable when you're actually constructing things from source.
Yeah.
So, and that is easier to do with Yocto.
Yeah, it's the same experience we've had. So,
yeah. And I think it's also one thing I like to add generally is, you can take these distros and then strip them down, sort of like top-down approach. But then it's easier to go ground up and then to go top down. So essentially, I think I've seen more than once that, such projects where you took like CentOS or whatever, and then, you started basically paring it down until it was not CentOS anymore. And there are like, weird kind of dependencies that appear, and, it's not that easy to pare down after a while. There are runtime dependencies, there are link time dependencies, there are like indirect dependencies. So, it's quite hard to get to that level. So unless like you can use the pre-provided profile, it becomes a little harder to, really have a solid system.
Yeah, exactly. I've done that. I've tried to take a kitchen sink kind of an image and try to get it down to exactly what I needed. And the dependency nest that you have to wade through makes that really difficult.
Yeah, and it's not maintainable because I think out there you're now customizing it to yourself, so it makes your life harder even to maintain such a thing. How do you you did describe about some genesis of the meta-tegra layer, and so could you talk to like what is OE4T and the meta-tegra and how it is kind of consuming various NVIDIA artifacts that are coming from their Linux distro?
Yeah, sure. So OE4T, or Open Embedded for Tegra, is the name of the project, which is really just me and a few other people, all volunteers, all doing this on our own time. We don't get any. We're not funded by any company to produce this stuff. And it was basically the outcome of my doing a presentation, I think, at a Yocto Project Summit about 4 or 5 years ago on meta-tegra, or my proposing to do that and saying, this was basically just me. It was under my own personal GitHub account, and I wanted to get more people involved. So came up with this sort of project name. OE4T had a nice ring to it because the original name for Jetson Linux was Linux for Tegra L4T. So we just called it called this OE4T. Yeah. And I just was trying to get more folks to get engaged with the project and try to get to participate and contribute. So it's the project itself, like I said, sort of stemmed from the initial work that I had done trying to get some products done, and it is a bit more general now. It covers more platforms. It has had contributions from some number of other folks. There are folks that we have a meeting every month by Zoom to just stay up to date on what's going on with the layer. And what's going on with Nvidia's BSP and where they are. Yeah, it basically, what it does is it takes the Jetson Linux offering, which is sort of two big chunks of things. There's a sort of umbrella packaging, umbrella name for their SDK they call Jetpack. But the core bits for the BSP are actually Jetson Linux itself, what used to be called L4T, which is the drivers, boot firmware, kernel, basically the low-level stuff that makes the platform run. And then the rest of the Jetpack packages introduce CUDA and all the interesting features are interesting to folks that are interested in this kind of hardware. So the layer supports both. You each time they do a new Jetpack release, that usually comes with a new version of the BSP. Usually it's a pretty small incremental version. Sometimes it's a big one, and then some number of the application layer packages get updated as well. So we have recipes for building, quote unquote, building all those. So we build as much as we can from source. NVIDIA doesn't, of course, provide source for everything in Jetpack, but the kernel is source, the bootloader their source. There wasn't always, but there is now, and they've been a lot better recently. Mainly, I think, because we and a lot of the customers who use their stuff that use Yocto to produce their products have pressured NVIDIA to do more source for things like GStreamer plugins and other sort of core bits of the system that live in user land, but interface with other open source, or open source packages. It's just a lot easier for us to deal with, like GStreamer updates and stuff, if we actually have the sources to the plugins that we're going to include. So the layer defaults to building as much as it can from source, and then just using the pre-built, like the boot firmware, the early stage boot firmware, we're never going to get source for. So those are binary blobs. Firmware for things like, the hardware encoders and other stuff. Obviously, we just include those as firmware blobs. And then all the Jetpack application stuff, CUDA and TensorRT and so forth, all that. What we do is we take those get shipped by Nvidia as Debian packages, and we basically have recipes that just unpack the Debian packages and then and install those binaries in the right places in the file system. So it's complicated to do, mainly because it's not very well documented, and there's some assumptions because they're using Ubuntu. There's some assumptions about what the environment looks like in some of their binary packages. So there's a few things that we have to do special to handle that situation. Mm-hmm. But for the most part, it's pretty straightforward once you've figured out the puzzle to fit it all back together the right way to make it work in your Yocto image.
So do you feel OE4T supports the full Jetson capabilities for like machine learning? If you want to do a machine learning application, is it fairly practical to do that on OE4T now?
Yeah, I'd say it's more suitable to use for runtime deployment of machine learning. If you're going to be doing data acquisition for building your machine learning models or whatever, you might still be better off using either using a full-blown x86 system with an Nvidia GPU, just to get the additional power that you might need for processing all that data, or perhaps even using like a development kit for one of the Jetsons with Nvidia's Ubuntu Linux, because that's really their target audience is developers. So they structure everything as SDKs. And they assume you're doing development directly on the target. Whereas my goal with the BSP layer is I want to build a product that I want to deploy to the field to make use of these technologies. Yeah. And that's kind of a different use case, and we're more streamlined for handling that sort of runtime use case than we are for like developer use case.
Sure. Mm-hmm. So do your training on some other system and then
exactly.
Yeah. Okay.
Yeah. So speaking of this, we basically have worked with Yocto project in some capacity, and so in your opinion, what makes a good Yocto board support package?
Oh yeah. Board support packages get a lot of hate in the community, I noticed, and it always gives me a bit of a pang when I hear people bad mouthing BSPs since I work on one. I think that the main reason, so good BSPs are hard to find, or good BSP layers are hard to find. Mm-hmm. Good BSPs are hard to find too, but and it's kind of related. One of the BSP layers that I worked with fairly early on was meta-freescale. Mm. And those guys I thought did a great job of putting together a high quality layer. And one thing that I noticed about that was that it's because it was the community that was supporting that layer, wasn't the stuff that was coming directly out of Freescale or NXP. And I think when you have the folks that are actually using the layer to create products, working on the development of the layer, I think that's the key to making it a really good layer. Mm-hmm. When it's the chip manufacturer or the module manufacturer, whatever, it's the hardware manufacturer that's putting it out there. They've got different goals in mind. They want to sell the hardware. The software is kind of a necessary evil to do that, mm-hmm. and the layer is there. If they have a layer, it's there to support doing their builds, to test their hardware to make sure it's working okay. They're not necessarily thinking about how customers really need what they really need in order to be able to deploy a product that's based on their hardware. Does that make sense?
Yeah, I think that's a really interesting insight. Just the collaboration with people using it is so critical, because a lot of these companies have a throw it over the wall mentality where we do it, we throw it over the wall. And some of them are actually quite resistant to any improvements we feed back.
Oh, sure.
So, that's really a tragedy, because that's how things could really improve. So,
yeah, I think some of them have like very, maybe intake process is not well defined. There's a legalities involved with it and all those, and they didn't think about those things. They
Mhm.
have made it a one-way street somehow, and then they never thought of like collaborative piece so clearly. And I think that also hinders quite a bit of them adding all those EULAs that kind of makes it difficult for people to contribute. And I think so. Moving on to that, so what are the common BSP issues that you see, especially from meta-tegra and other places?
Yeah. So I think one is just the general quality of software that that comes out of chip manufacturers. I hate to be overgeneralizing, but I've seen this stuff from a number of chip vendors, and the software that they write is almost universally terrible.
Hmm.
At least that's in my humble opinion, or maybe my not so humble opinion. Um, it's and again, it's hard. They probably have a team of junior engineers that they're pounding on for deadlines to crank out stuff, and it's not necessarily, if they're lucky if they have an architect working for them that kind of has a good enough understanding of the whole picture to know what works well and they're probably targeting Android or Windows or before Linux, generic Linux. They're probably targeting some particular market that is using a particular operating system where they don't, the cleanliness of the code, because it may or may not ever really be public, isn't necessarily top of mind.
Yeah.
So that's but I think the bigger I hate the bigger problem really is just the complexity of the hardware.
Yeah.
Back when I was first starting out in programming 50 years ago, processors were a lot simpler and easier to understand, and peripherals were all discrete, sometimes at the end of really long, thick cables that, channel cables that you would attach to your mainframe. And these days, the level of integration in these SoCs, or these systems on modules, which are really just SoCs with RAM and some other stuff on them that have been put together because they're known to work. It's amazing the amount of capability. You look at one of the Jetson modules, and it's just the amount of stuff they've packed into these chips is incredible. And making all that hardware work properly together is a huge task. And making that work for a variety of general use cases, I think is a really hard task. So I think it's challenging just from that aspect to make that the drivers good and to make their BSP offering good.
Yeah, maybe that speaks to why they basically do a dropout. It's essentially it's like they say they target a release which is quite old, and they kind of park it there, never move to the next release, because I think that work is so complex. And then maybe they could do a little bit of thinking around, like how can we make it such that it can be put into new releases easily and things like that, and not make it like this is the release will go until the end of the life of this hardware or something like that.
Yeah, because there's always some new technology around the corner that they want to integrate new IP into their chip for, and maintaining this old stuff that they developed 5+ years ago versus chasing the new thing, where you're going to get more buzz. It's going to be chasing the new thing.
Yeah, I'm curious, Matt, when you for the OE4T layer, do you develop on master, or do you do most of your work on a Yocto release, or how do you kind of do that?
So I try to keep up with OE Core Master. not at necessarily every day, but I do try to keep our layer up to date on a fairly regular basis. So at least a couple of times a month, I'll do an update for master, or if I know something's gone into OE core master that's going to potentially have some impact, I'll try and hit that off at the pass and get meta-tegra updated so it's compatible. I don't. What we have documented in the wiki for the layer is that master is never considered stable, so I don't never recommend that use of master for people actually trying to develop a product. Depending on where they are in the life cycle. If they're just starting out, maybe, and if they're used to living on the bleeding edge, maybe. But in general, people building products, they probably want to pick an LTS type release. So there's a lot more focus from the folks that use the layer on the current LTS release, or sometimes older releases, the kind of LTS that maybe aren't supported anymore. I think we still have folks using Dunfell, for instance. They still haven't migrated to Kirkston. It's hard. It's hard when you're developing a product with a long life cycle to work in those kinds of core infrastructure updates on a regular basis, depending on what your corporate culture is like. So yeah, it's a bit of both. I accept pull requests off of one of the LTS branches, but for new like BSP updates and stuff, I always try to get those into master first and then backport them to the LTS branches that we're supporting.
Yeah, that's excellent. I see that pattern a lot with people that are producing good work in the Yocto space. They have a master first mentality and then they backport, and that really seems to have an impact on how well things are maintained and the overall quality.
Yeah, it's a question of spreading out the effort over time. So if you stay on top of master and updates is more incremental usually to do that than it is to focus on Dunfell and then worry about Kirkston when you really need when you're forced to make that move. And now you've got 4 years worth of updates in OE core that you've got to try and sift through to figure out how to make that transition. So in general, even if you don't use master for production builds, but you at least keep it sane enough that things aren't totally broken. I would definitely recommend that for everybody. That's one of the things that I learned in the first few years that I was doing the layer. Wasn't something I had thought about initially, but it's made things a lot easier over time.
So do you use any sort of CI or any automation for your work?
I do only for builds. So and I have my own. It's my own adaptation of BuildBot that I kind of borrowed some concepts from the Yocto Auto Builder, but it's not nearly as complicated. So there's a BuildBot that runs every PR for the meta-tegra layer, triggers an automatic job that runs through Yocto check layer to make sure that we're not breaking things. That's another thing I learned as I was developing the layer is running Yocto check layer regularly to make sure that the layer is clean and isn't going to interfere with other layers in the build. That's another good thing. And then I also have a demonstration distro for each of the branches we support, and I've got automated build jobs that run. And then every time I pick up a new batch of core layer updates, or we've got a batch of updates in meta-tegra, or that also pulls in meta open embedded and meta virtualization, I think, is the other layer. Because we have we have container support in the Jetsons. So we've got that demonstration distro, and I just keep that up to date, usually once a week. I'll check to see if there's any significant updates and get all the layers updated in there, and those run automated builds for across a significant subset of the Jetson platforms and images we would build for those, just to make sure that the builds are still good. I don't have any automated actual testing of the hardware. I've always found that to be really difficult to do on a shoestring budget.
Yeah. And so, are there like any, ideas you have around how this BSP situation can be improved?
Yeah. I mean, I'd like to go back. I'm not sure how well the Meta Freescale project is going in terms of the relationship between NXP and the community of users. If there's things that I don't have, and I have no great ideas how to make this happen, but I think building a community around significant BSPs and getting more participation from the folks that are using it would be a great way. Or having open source project style layers that are independent of the ones that the chip manufacturers themselves make, kind of like the way Freescale worked and still does. I would recommend that to anybody that was doing that, and not just do that once the chip manufacturers abandoned whatever chips, and the open source project just looks at the upstream support in the Linux kernel. I think that's the other aspect of meta-tegra that has been important, I think, for the folks that are using it, is we need to have that downstream support in order to make use of the interesting functionality in the modules. And because if we just wanted to be able to boot Linux and run Nuvo, you could do that with upstream stuff, but you don't really need a BSP layer to do that. It's really the value in using these processors is that functionality that's really only unlocked with the vendor supplied downstream stuff. And being able to do that, make that compromise between open source land and the vendor supplied stuff that you really need to have is important.
I think the true North Star is always that everything is upstream in kernel and wherever, and everything works, but that's far from reality. And I think essentially, I think what you said is exactly the right thing, that you will have to use those features that are not yet upstream or on the way eventually, but you need to ship products today, and then how do you do that? So
right, exactly. Can't wait 10 years for it to show upstream.
So you have worked with Nvidia products quite a bit. So I know that they've been doing various things. So what makes them different or unique? And what are some of the applications you think that that they are being used? I mean, we know AI for sure, but from like IoT perspective, or is there a leverage of AI into edge? Where do you see that?
Yeah, I've seen. We've got a bunch of users from a bunch of different verticals that have been trying to apply. It's really just, do you have an application for heavy duty compute in either an appliance or something that is on the edge and lives close to whatever it is, whatever product it is you're working with. And I think they're, in terms of the hardware and the compute power, they're pretty great in that respect. And if you need video processing, depending on which model of the Jetson you're working with, there's hardware encoding for like H.264. There's lots of video stuff. and graphic stuff that you can take advantage of in there too. Or if you just need a really, powerful little processor for just ordinary everyday computing, they're pretty nice from a hardware design standpoint. Pricing wise, maybe not so much. The all that power comes at a premium.
Yeah.
But the it also that it's an ecosystem that there's probably a big talent pool for, in terms of folks that understand how to work with CUDA, and even though the desktop discrete GPU environment is different from the combined CPU GPU with the shared combined memory that we've got in the Jetson modules, it's similar enough that you can take application developers that are familiar with doing stuff in the discrete GPU land and have those skills transferred directly. Mm-hmm. So there's a lot of good reason for using the Nvidia. Not that I want to do a sales pitch for them, but but yeah, if you can live with the high cost, they're nice little processors.
Pretty cool. So I think if you look at like the landscape, I'm pretty sure that you mentioned you worked on various companies, so I'm pretty sure you're dealing with open source, you're dealing with closed source, maybe third-party closed source. And so how do you deal with that mix?
Yeah. Yeah. I think, in general, for, obviously open source, you want to have this, you want to have the source as much as possible. You want to have that untainted. And I don't want to deal with companies that give you GPL, something that they built off GPL source, and then they don't make the source publicly available. I mean, I know they only have to give it to you since you're the customer, but just never been happy with folks trying to take advantage of open source as a kind of a one-way gimme instead of being the collaborative thing.
Yeah.
Closed source, I mean, sometimes you deal with that. One thing, when I've worked with, like, we've had third-party suppliers that needed to provide us with proprietary software that needed to combine their stuff with in an environment that worked for us. I'd like build an SDK for them out of our Yocto build environment, that provide them with an SDK so they'd have all the tools. They could cross build it with the SDK and provide us with the binaries. That was one way to deal with closed source on a sort of purely practical level. And so that's another reason to use the Yocto project, because actually generating those SDKs is one of the nice features of the system. So the tool chain's all there, and all the dependencies are there, and as long as the third-party provider is willing to keep up with your updates, and you ship them a new SDK and they build you a new version, then that works pretty well.
Yeah.
Otherwise, you get into legal and licensing related stuff that I kind of stay away from. I mean, you guys must work with a lot of BSPs too, though, right? I mean,
yeah.
Do you find and you find some are better than others, or?
Oh, absolutely. Yeah, I've seen some real nightmares, and the worst ones for me were the ones where they've like just completely veered off the track and built all this custom tooling and like graphical configuration tools and stuff inside the layer. It just makes it a nightmare to like integrate with our Yo distro. It's pretty much just a one-off at that point. And I've been doing some Zephyr development, and that's a really fascinating project in that they've convinced all the chip makers to bring their HALs to the project and integrate with the Zephyr project. And I've wondered what would happen if Yocto did the same thing. If they've convinced the all the chip makers, bring your BSPs, let's integrate them all in one build. Get to the point where they all play nicely together. There's a common set of standards for what's good and what's bad. I don't know. To me, it just doesn't seem like they're going to make any progress unless we solve this integration problem. But I could be wrong. That's just kind of how I see it, comparing it with other projects right now.
Yeah, I think part of that is, I think that's just hard to do with
Mm-hmm.
the Yocto tooling too. I mean, it's way too easy to miss out on things that that are important for making a good layer that works well. Like, you need to customize the build of some common package that there's a recipe for it in OE core. So what do? Well, you add a BB append, and you change the way it gets built.
Mm-hmm.
And now you've done that in your BSP layer, and now everybody that's doing a build is going to pick up that BB append if your layer is included, and that's going to change things. And it's just too easy to shoot yourself in the foot that way.
Yeah.
So part of it is, I think, it's just sort of the complexity of the tooling, which means there's a steep learning curve with Yocto tooling, and because I've been doing this for years and I still learn new stuff. It's a complexity that kind of needs to be there in order to be able to support everything that the tooling needs to support. So we're kind of stuck between a rock and a hard place. But if there was some way to kind of pull the different BSP vendors, the chip vendors in to kind of get them to commonize a BSP standard under the Yocto project umbrella, I think that would actually be pretty cool.
Yeah, I think the Yocto compatibility program is meant to be some of that, and essentially, it's trying to up the ante a little bit on various things, with various aspects. But the problem space is too big. Essentially, if you look at something like Zephyr, it's well-targeted project. It's on microcontrollers. It's quite complex, but this community space is still monolithic in nature. People build Zephyr and then there's an app on top. But I think here we have legacy with Linux, and then people take same Linux they want to use on other distributions and Yocto and everywhere. So, if you put silicon vendors hat on, they see, oh, can I do it once, and do it everywhere. And then they, in search of that, they end up creating a fourth standard that they are doing, and then they try to disseminate their work to, okay, here is for Fedora, here is for Yocto, here is for Buildroot and whatnot. So, and in the end, I think, if you adopted those as standard tooling, especially if you're in the specific market like what Freescale did, and some of the layers are really good examples in Yocto community. So it's not that it doesn't exist. It just requires some level of work. And I agree. I think if the compatibility program did some good stuff, in making sure that somebody can throw their layer at the compatibility program and it gives them good feedback, and make sure that all the hot buttons are not there, and things are inert when layer is added, not active. So, and all that kind of stuff would help. I would think quite a lot.
Yeah, it is a hard problem though.
Yeah, it's very hard.
And it would maybe be a little easier if everybody was like based on x86, or if it was limited to single architect or a single chip design. But particularly with ARM, there's so many variations in boot flow, and how the ARM chip vendors got a lot of leeway in how they put together those early boot stages, and trying to adapt that. I know that's always been a problem with the meta-tegra stuff too, is the initial flashing of the device to get that initial software load on there. It's there's a lot of Nvidia specific tooling in that mix and scripts, and it's really hard to develop and really hard to maintain too. So, and trying to do that and trying to standardize something like that across, because I would get people asking, well, how come we can't just use WIC? Like we do for these other platforms. Well, it's because you're welcome to try to make it work, but it's really complicated.
Yeah. I think that flash map layout and everything is so much controlled by what kind of chip it is, that it defines quite a bit of workflow.
Yeah.
Especially around updates or flashing, as you said, of factory install and all kind of stuff.
Yeah, and secure boot related stuff.
Secure boot, yeah. I mean, there is some hope with the system ready that ARM has put together in terms of spec.
Yeah.
Now it remains to be seen. The whole ARM ecosystem adopts it, and this five is doing something similar with OpenSBI, and I don't know. I think at least people are thinking about this stuff. Hopefully, something will come out of them.
So I was going to say, just as we solve this for ARM, there's going to be RISC-V, but you're right. I mean, OpenSBI is an attempt to at least prevent that from getting too out of hand. But we'll see.
I mean, they will do their share of mistakes too, So we'll see. So what do you see? Where is embedded Linux headed? Now that Cliff mentioned about Zephyr, and Zephyr is basically becoming quite a platform, for a lot of complicated applications, even graphics and other stuff. And, where, in past people tried to get like embedded Linux because, the RTOSes of that time weren't good enough. So where do you see embedded Linux headed to? Is like, Yocto the future, or is there something more?
That's a good question. I think embedded Linux is complicated. It is more complicated, I think, now than it was, because if you talk to somebody that was doing embedded Linux, say 10, 15 years ago, it was probably a low end discrete processor, maybe starting to look at some systems on a chip types of things to run Linux on, but it was still a fairly limited amount of functionality. We're still fairly constrained in terms of space and CPU power. When I started working with these Nvidia processors, these are like server class systems in this teeny space, and you want to make use of those server class features. So it's embedded Linux system looks a lot like a server or a desktop if you've got some kind of interactive display on the thing. So trying to figure out where the dividing line is, that we used to think, well, embedded is kind of this space down here, and then there's everything else. I think that's gotten blurred over time, and as we put more and more power into these devices. So I still think Yocto is a great way to organize your builds, know what you've got in them, and put together a custom distro for managing this stuff. I don't see that stopping, unless things like Rust and some of these other new technologies that kind of don't fit with the traditional packaging model that we've all become used to in Linux land. Unless those start to grow enough that it has to evolve to accommodate that. But I mean, what is embedded Linux these days is the big question. What really counts as embedded when you've got gigabytes of DRAM and potentially terabytes of storage to manage the kinds of complex applications we're actually putting down at the edge of at the edge of the network these days.
I think that's very well said. I think essentially around embedded, probably that embedded word probably is not fitting it anymore. And
maybe
has grown up.
maybe Edge is better or something like that. So
Yeah, yeah.
Yeah, I don't know. It's yeah, it's there's a lot of stuff going on out there. It's
Mhm.
hard to keep track of it all. Um,
So,
and
anything new you're following or you're passionate about these days?
um, man, there is so much going on. It's hard to keep track of it all, really. And certainly of late, I've been sort of heads down with some work at my day job that I haven't really been had a chance to poke around with anything interesting. I mean, I've looked at Risk V a bit. I've got a board and I've played with that a little bit, but I haven't touched it in quite a while. And I think that's interesting just from the general direction of where CVUs are going. Um, the there's AI stuff that I've got at work that I don't work directly with, but it's certainly interesting to me, and a lot of video processing um, and and how that works. Some of the technology that's coming around in handling that stuff is interesting. The one thing that I know it gets a lot of buzz that I haven't looked at really at things like Chat GPT and that whole family of large language models. I don't know. Have you guys played around with that stuff a lot? People tell me, "Oh, you should try it because it'll write your code for you." And I'm not that much of a technology fan that I'm ready to just jump in on all the hype and go for it. I'm always a bit skeptical about this new stuff.
yeah, I find Perplexity pretty useful as a substitute for Google. It's you don't need to log in; you just pop it up like Google and do a search, and it summarizes. So to me, it kind of cuts out one step of having to click on a link and then go read it. It kind of seems like it does a pretty good job at summarizing, but yeah, I don't know. That's probably the biggest benefit I found.
Yeah, I use it too. I mean, I like the reference thing because I think if some system is telling me something and there are no references, it might be hallucinating, and they are
Mhm.
very forthright and very confident in telling me a wrong answer, and I'll believe it, right? So I kind of want to avoid that, and then Perplexity meets that. When I read that gist and they have the references underneath, so I can go and click from where they found the information. So it's good in that way, that sometimes I need to quickly find out something, and it tells me if I need to dig more, then I have links or I can interact with it more. So I think it's a good mix right now.
I'll have to give it a try.
So, Matt, any advice for young engineers who might be listening to this podcast?
Oh well, not that they, uh, not that anybody needs to hear what an old fart thinks, but there's lots of ways you can grow your career. Find something that you like to do, that you're good at, that you get a charge out of, and just run with it. That would be my advice. I mean, that's pretty much what I've done. I won't say, I'm certainly no Elon Musk in terms of, and if that's how you measure your success, well, good for you. But, I've got a happy life, have a lot of fun doing the stuff I do, and I'm not sure you could ask for more.
Yeah, well said.
Thank you, Matt. This was really awesome, very insightful. I think we learned ourselves quite a bit about the meta-tegra and generally what you have been involved with. So thank you for all the insights you shared today. So thanks everyone. And if you have any comments, please reach out to us or provide us feedback or stars.
Yeah, appreciate all our listeners and let us know your thoughts. Thank you.
Thanks, guys, for having me on.
Yeah.